Imagine yourself as a marketing manager at Parch & Posey. You want to compare Facebook as a marketing channel against all other channels. You know Facebook is a great channel for your business, but is it better than all the rest combined? Let's find out. In order to do this, you'll need to create a derived column. That means you'll take data from existing columns and modify it. In previous lessons, we did this using arithmetic. For this application, we'll use the case statement, which is SQL's way of handling if-then logic.
The case statement is followed by at least one pair of when and then statements, SQL's equivalent of if-then. It must finish with the word end. As you can see, the case statement checks each row to see if the conditional statement, channel equals Facebook, is true. If so, it results in the value yes being printed in the column is Facebook. If not, that row's value in the is Facebook column is left null. This query makes it pretty easy to see what's happening because we've included the case statement along with the channel column itself. You can check each row to see whether channel meets the condition channel equals Facebook, and then see the result in the column generated using the case statement. Now what we'd really like this query to do is fill in those nulls with the word no. We can do this with the else statement, which provides a way to capture values not specified in when-then statements. If we want this new column to keep track of not just our Facebook channel, but also the direct channel, we could change our case statement to use the OR operator. The when statement is a logical condition similar to what you would put in a where clause, so you can use and, like, in, or any other operators you've already seen. Imagine yourself in operations at Parch & Posey. You'd like to classify orders into general groups based on order size to get even more granular about inventory planning. You can use a case statement to define a number of outcomes by including as many when-then statements as you'd like. In this example, the when statements will get evaluated in the order that they're written. So if the value in the total column of a given row is 600, it will produce a result of over 500. If the value in the total column is 169, the database will first check to see if the total is greater than 500, because that's the first when statement. 169 is not greater than 500, so it will move on to evaluate the next when. This process continues until a logical when statement evaluates to true, in which case the then statement will be recorded in the total group column. For 169, this would happen when the when statement results in 101 to 300. While the above works, it's really best to create when statements that don't overlap. The conditional statement when total is greater than 500 overlaps with the statement when total is greater than 300 for every value greater than 500, which is a little confusing. A better way to write the above would be to define specific groups that don't overlap with one another. You can do this by stringing together multiple conditional statements with and or, the same way you might in a where clause. In the final parts of this lesson, we'll take these casements just one step further by combining them with aggregations that we looked at earlier.